Hello, my most excellent students. I wanted to do a little video for you today because we did not have any time today to talk about how to use the Windows calculator to do scientific notation, and I wanted to be able to do that with you. So I thought I would show you how to use this using an example from the book. This is on page 145. It's straight from the book. It's going to pretty much look the setup just like is in the book. However, I want to show you how to do that with the calculator. So first of all, find your Windows calculator. So it's either down here in the taskbar, down here below, you'll see it, or you might have to find it in your programs. Oftentimes it'll be up here under accessories, and you'll see calculator. So if you open it, it may not look like this when you first open it. It may look more like this. That's the standard calculator, but the standard calculator is not going to do what you need to do. You need to make sure to put it in scientific mode by using the view button and clicking on scientific. So here we go. How would we do this? Well, the first step really doesn't involve any scientific notation. Remember, we've been given this conversion factor 1.00 AMU equals 1.6 times 10 to the negative 24 grams. That's just a given. You need to know that's given. This is not a precise number, so this is going to be a limit to our significant figures, 3 significant figures there. We'll use that later. But the first step is we just have to figure out the molecular mass of this compound, silicon fluorine oxygen. I'm not even sure what it's called, but that's okay. So this is the formula. So we'll do that just the same way we did today in class. So first step is we have to figure out up here, and we'll look at the periodic table. We see that one atom of silicon has an atomic mass of 28.1, but we see that we have 6 atoms of silicon, so we do 28.1 AMU times 6 to get 168.6. Fluorine, we can see over here, the atomic mass, meaning the mass of one atom, is 19.0. Again, we have 12 here, so we do 19.0 AMU times 12 to get 228.0. Same thing with oxygen, the atomic mass, 16.0 times the number of atoms, 6. 16.0 times 6 is 96.0. We add all those up to get 492.6, which is the molecular mass of this compound. Hopefully you figured that out from class today. If you can't do that, you need to make sure you can work through that pretty easily. You'll have to do that a lot in the upcoming chapters. But let's move on to using the calculator. So the next step is we're going to use our factor label method. And again, whatever you're given, in this case it's 492.6, so you weren't given it, but you figured it out. You're going to put 492.6 AMU, the mass of this molecule, over 1. That's what we're always going to do. We're going to multiply that by this conversion factor. This actually should be format font to the superscript. There you go. So we're going to multiply that by this conversion factor. Once again, we can turn this upside down either way, but because we want to get rid of AMU, we're going to put AMU down the bottom. So then we can take our marker here and we can cross out our AMUs. No, we can't. Hold on just a second here, guys. There we go. We can now, I think we can do this. We can cross out our AMUs. Right, all we get left is grams. And now we're going to multiply straight across here. Now, how do you do that on the calculator? That's where this comes in. First number's easy. 492.6. It's not easy. Turn off draw, sorry. 492.6 times 1.66. Now this is where it gets tricky. You gotta watch what we do. Gonna hit the exponent button here, right down here in the bottom left, exponent, and it says 1.6 times e plus 0. We're gonna do to the negative exponent, so we hit the positive negative button here, and we're gonna put 24, and then we just hit equal. And that gives us a really long number that obviously would be better written in scientific notation. So now we're going to use the FE toggle switch right here. That's going to toggle this to a scientific notation. Obviously, we're limited to 3 significant figures here, so we're going to have to round this to 8.18 times 10 to the negative 22. So that would look like that. This would be our answer here. Now again, if we wanted to do this to the kilograms, we'd have to divide by 1,000, right? Divide by 1,000, and that's going to make our exponent, negative exponent, a little bigger. Means it makes our number a little bit smaller. So I don't know if that's helpful. Hopefully it will be. If you don't understand or if you have questions, you certainly can email me. I'd be glad to help if I can.